And thanks a lot for joining this out of your busy schedule. I would like to quickly maybe introduce us. So we have Dr. Deva Henry, who's a principal consultant with us at BlueKai, and we both will be your facilitator for the webinar, and it will be largely driven by Dr. Henry. So maybe I'll just like to introduce quickly myself, and then I'll hand it over to Dr. Deva for the webinar. So my name is Mudit, and I'm the director at BlueKai Solutions. I have about 13 plus years of industry experience, mainly coming from electronics background, and about 7-8 years of experience into focusing mainly on MBSE and overall system engineering adoption across the enterprise. And then at BlueKai, been involved with a lot of consulting and training projects. So one of my core interest area is MBSE, model-based systems engineering, and a lot of simulations. I got my formal master's at MIT in system design and management. And that's where sort of formally kicked off into systems engineering as well. I'm associated with Incose India as the current president, and then I'm also the co-lead for Incose India MBSE local working group. So really looking forward to this webinar and looking forward to a lot of engagement through this webinar with all of you. Over to you, Dr. Deva.
Thank you, Mudit. Good afternoon, everyone, and welcome again to this webinar. To quickly introduce myself, I started my career after a BTech in aeronautical engineering from Madras Institute of Technology. I joined the Aeronautical Development Agency in Bangalore, worked on the LCA program, the Tejas aircraft Air Force version, as well as the naval program. While at AD, I went to IIT Bombay for my master's in aerospace systems engineering. That was my initiation into systems engineering, got interested in the field, and came back to ADA, did some work, and then got an opportunity to go to the US for my PhD and went to Stevens Institute of Technology, did my PhD in systems engineering there. While I was there, I also was involved with the Systems Engineering Research Center, which is a US Department of Defense sponsored research center, did a number of projects there, did some teaching as a lecturer, assistant professor. And then a couple of years ago, decided to come back to India. After coming back, I was associated with the drone industry for a while, and then wanted to pursue a more focused career in systems engineering. So now I'm doing consulting training and trying to promote the discipline of systems engineering and develop the discipline in India. So that is where I come from, and really happy to have all of you here. Very quickly, we have a very wide variety of participants. When you look at the years of experience, many of them have under 5. This is information from the registration forms that we had requested you to fill. So less than 5 years is a predominant part of our webinar audience today, but then spread across right from 5 to 10, and even some who are over 20 years of experience. So this is a wide variety of experiences. Also coming from various different industries, defense, aviation, aerospace is a big set here, but software, IT, mobility, transportation, healthcare, electronics, a number of them from academia, civil and construction. So we have all the mix of experiences in industry, and these are some of the names of the organizations that participants are coming from. So this is a very wide mix. So we'll try to address something that will be of interest to all of you. Looking back at why this webinar, the first reason was to help transition from theory to practice, because this was a question in my own mind. Okay, so when I started looking at systems engineering, this is interesting, it was applicable, want to do more with it, but how do I implement it? What do I do next? When I taught students, if they were students from the industry doing their master's or PhD, again, that would be a question. Organization is not doing a lot of systems engineering. I'd like to take an initiative and do something in my organization. What do I do next? And back here in India, whenever we do a training or a seminar or any seminar on anything on systems engineering, that is one of the first questions that is asked. There are things that we are learning. There's probably theory and a little bit of skill development as well. But how do I take it into the organization? And so that is the motivation for this seminar, to kind of help you get started with systems engineering at your workplace. So wherever you are, whatever you're doing, how best can you take it from here, take systems engineering into your organization. So that is the focus of this webinar, to give you also an approach that is agnostic of whichever level of system you're working at, which domain, which industry, which organization. So we are trying to give you something generic, and naturally there would be a customization, there would be something that that you would like to adopt in your organization, which is very unique to your organization. So that factor will always be there. But in the limited time of these 2 hours that we have, we want to give you as much of an immersive hands-on experience that we can. And a couple of things that we want to say up front is that after this webinar, it's not that you will be ready to go and implement. There will be work to be done, but we will give you probably a direction and some pointers. This webinar is not on systems engineering, so we will not be talking much about what systems engineering is or its approaches, methods. We are not going to focus on that. It is more about implementation. But when you leave this webinar, we hope you have more questions on your mind than what you have right now. And that is what is going to get you started in the direction of implementing systems engineering. Okay, so that is kind of what we have in plan for you over the next couple of hours, and I hope it will be interactive. We will have some breakout sessions, we'll do some polls, and we will be taking questions throughout. So whenever you have a question, drop it in the chat window, and we will take it up towards the end of the webinar. And our contact information is also available in the emails we sent you. So even beyond this webinar, we are available for interaction, for discussions. And so let's get started. So to answer the question, what next? I wish to implement systems engineering. What next? So we have put together, based on what we have seen, based on our experiences, based on our interactions with industry, and the experience I've had interacting with a number of systems engineering organizations in US, Europe. This is a culmination of all that, and we have just concisely going to present you a 6-step systems implementation, engineering implementation process. So these 6 steps look something like this, and this rest of the webinar is going to be how we are going to look at each of them. So where is systems engineering being rendered? Why do we need systems engineering? What activities? Who will be performing them? How will they be performing them? When will they be performing them? So this is the framework with which we are going to approach our implementation. And as you can see, there are a lot of questions. And in some sense, doing systems engineering involves asking the right questions at the right time. And this is kind of what we are doing as well. Even when you look into systems engineering and want to follow a systems engineering approach, there are things that you need to do upfront, and that involves a lot of thinking and a lot of questioning. And so when you look at implementing systems engineering, typically that is what you would be doing as well. You will have to think a lot, you will have to ask questions, and then to try to find answers to that, and that is going to help you go ahead with your implementation. So we are going to look at all these 6 questions, and there is a sequence to this as well. So we are going to start with where, go with why, go with what, and then split into who, how, and when. And there is a method to this chaos. So that's why we want to present this in this way. But as you can imagine, this is not something that can be strictly sequential. This is the approach that we recommend on how you start looking at these things. But once you start looking at these things, addressing these questions, you will have to keep coming back. You will have to iterate. You will have to go back, move forward. All those things are going to happen. So be open to that. And before we actually jump into step 1, there is always a step 0, right? So there is always a step 0 that you need to do in preparation for this. So this is where you need to have a common understanding. This could be with respect to your organization, with respect to your team. When you look at systems engineering literature, when you look at INCOSE resources, when you're looking at, let's say, a MITRE systems engineering handbook or NASA handbook, or any such resources that are available, or you're looking at some papers or other things published by INCOSE, you need to make sure that you're all on the same page in terms of understanding what some of these things are. It's good to assume that we probably will have different ideas and concepts. So even as simple as what is a system, what is a subsystem, what is systems engineering, what is MBSE, it's always good to have a common understanding. In some cases, there could be a conflict between what your organization says and what INCOSE says, for example. It is better to bring those out and make sure there is a common understanding on which you are building the rest of your implementation. So, because right there, if there is a difference of understanding of what systems engineering is, for example, or what MBSE is, it is better to do it upfront rather than trying to address it later on when there is some challenge of some kind. Okay, so I also wanted to get a sense of from the audience, from the participants, what your familiarity is with systems engineering. So we are going to do a very quick poll here, and we just have pick a choice, pick a number from 1 to 5. This is on your familiarity with systems engineering, not necessarily how much of systems engineering you're actually doing or how good you're at it. It is not about that. It's purely about your familiarity. So if you've just heard the term but know nothing more about it, 1. If you have heard others use this term a lot, but you're not very sure what it means, you hear that a lot, that could be 2. 3 is you are aware of systems engineering as a discipline, not just as a term, but as a discipline. But you don't know much about it. You are aware that this discipline exists. You are a little familiar. You have heard about things, read about things, attended webinars like this. So you are a little familiar with systems engineering. And number 5 is you know many aspects about it. You've probably had formal education in it. You are a systems engineer in your organization. You are performing systems engineering. So between 1 and 5, what would you choose? So I believe the poll would be coming on now. Okay, so I think you can see the results as we watch. Okay, I think most of you have answered. Still a few options coming in.
Yeah, it could be possible that those of you who are joining via browser might not get poll. I'm not sure.
All right. So I think we've got 90% of the participants giving their option, so which is good. So we have mostly 4 and 5. We have a few 2s and 3s. So again, it's a spread. But for those who chose 2 or 3, again, want to remind you that the focus of our webinar today is on implementation. So to understand a little more about systems engineering as a discipline by itself, what it contains, what its approach is, this webinar will not directly answer that question, but hopefully this webinar sparks some interest in you to go and explore that further, to understand more about systems engineering and look for other resources that can build your systems engineering knowledge and capability. Okay, so I think all right, so we will go on. So thank you. We see a lot of 4s and 5s, which is good for what we want to do here. Okay. So let's get started with step 1. Okay, which is where is systems engineering being implemented? So this is where you set the context. So if you remember, in a systems engineering approach, typically you would draw a context diagram very early on, which defines the boundary of what is inside your system, what is outside your system. It kind of identifies what are the external entities with which your system has to interact, and what will be the nature of that interaction, what will flow and in which direction. So at a very high level, a context diagram helps you draw that boundary for your system of interest. So when you think about implementing systems engineering, it is good to think about that context before you jump in. Okay, so in the context of systems and projects and organizations, it is good to understand what it is, where you are, and then clarify. So you cannot do anything about this it is something that you need to take a moment to understand, and that is going to help you in your systems engineering implementation. Okay, so for example, you have a typical system, and these are the generic 6 life cycle stages that INCOSE handbook talks about, 15288 standard talks about. In your organization, it would have a very different life cycle stage definition, but for purposes of this webinar, we are just using the INCOSE 6 general stages as our life cycle stages. So you can, this is from the point of view of the system, a system that is getting developed. It's a car, it's an aircraft, it's a ship, it's a consumer electronic goods, appliance, whatever it is. So this is your system, and this is the entire life cycle of that system. The organization that you are a part of need not address the entire life cycle. So you could have an organization which is more of design development, where it focuses on a concept stage and development stage of an organization, right, of the system. So when I was at ADA, ADA designed, developed the LCA, and it was produced by HAL, it is operated by the Indian Air Force, it goes out of hand. But the scope, and as a designer, I'm thinking about the entire life cycle of the system, but the scope of my organization is design development. So within that scope, the organization defines projects. So you could have a project within an organization that does something in the conceptual stage. There could be an organization which with another project which looks at just the development stage of the system. So this is how you would see a project and an organization and a system get connected. So this organization is good in design and development. So it could have another system that it is working on as well. So there is a system 2 that an organization could start looking at, a next version of the aircraft, or a different automobile, or a drone with a completely different application. There could be another system it is looking at. And for that system, it would have a common project that runs across both conceptual and development stages. Okay, so this is how your system, the project and organization can be arranged. So from your point of view, think about which project you are in, which projects you have been in. How does it form in the organizational context? Are there similar projects, one project supporting multiple systems, and which part of the life cycle are you looking at, right? So all these are part of the context. So understand this, because this is important for systems engineering implementation. So understand where you're located and which part of this you are thinking about when you're talking about implementing systems engineering. Now there's another context as well, where you could have, as we just saw, a system and an organization that is looking at concept and development stage. It is very common to have a subsystem that gets developed by another organization, or it could be a unit of the same organization. You can have an MNC where the parent company is somewhere in Europe, they do the whole vehicle, and a part of it, a subsystem, is done by the India unit, and that is where you are. But in the overall scheme of things, for the overall system, it is some activity that is happening within the development stage. But for this subsystem, that subsystem goes through its entire life cycle. So starting from concept stage right to the retirement stage, you could have a subsystem development that cuts across the life cycle. And this could be done by an organization, completely different organization as well. Okay, so there could be another subsystem, like a third subsystem, second subsystem done by a third organization. And again, that could have its own life cycle. So when we talk about implementing systems engineering, are you talking about the subsystem that your organization is working on, and which may run through its entire life cycle? But when you look at it from the view of the parent organization, you are all doing something with respect to the development stage. Okay, so all these things are possibilities. And when we look at our own organizations, our own roles, our own discipline, our own units, our teams, how we are organized within the organization, all these things matter. So the first step is just to clarify where you are, what is the context, because that is what is going to matter when you want to implement systems engineering. So if you are here in organization 3 looking at subsystem 2, you can think about systems engineering implementation here. It may not be so easy for you to think about something that goes beyond the organization 1 and beyond what their scope is. Okay, so this is something, as I said, not something that you can really do anything about, but something that you need to be aware of, and that is probably the first step that you need to do. Okay, once you do that, we have finished the where, understanding the where, and now we go into the why. Why do we need systems engineering? What benefits can you get? Okay, so to do this, we're going to do a little exercise, and I'm going to hand you over to Mudit, and Mudit will explain that, and we will go ahead with that.
Sure, thanks, Deva. So basically, what we are looking over here is that why is really system engineering required? And in this exercise, you'll be sent into different breakout rooms. So I think we'll be doing 3 breakout rooms overall. And there you need to answer these questions. So how can system engineering be of help? So what is really the intent behind adoption of system engineering, right? Is it going to solve a problem, or is it going to increase efficiency? So whatever comes to your mind, whatever your intent has been, the reason for coming to this webinar, and all those questions, try to answer them. And then different ways, you can ask the same question, like what do I wish for system engineering to solve? Where can system engineering make a difference? So we are also talking about which part of the organization, which subsystem, which project. So try to address all of those things, and we'll be now breaking up into the different breakout rooms. There, one of us from our team will be there to support you, but we'll be also dropping a PowerPoint file where you can capture the notes. So maybe we'll ask one of the team members from in each breakout room to act like a scriber, and he or she can then take notes, and then we'll be coming back after 15 minutes and doing the discussion. So yeah, so we'll now break out into the rooms.
Ajit, you need to join room 2. Ajit, can you hear me? I also see Arpit, Deepti and Avinash. Any challenges in joining the breakout room? Hi, I think
Hi,
Ajit
Siti. How are you?
is. Hi, Ramesh. Good. How are
Hi,
you?
hi.
I
Good,
think
good.
Ajit got disconnected. He was supposed to be in this room. Let
Oh, okay.
me just drop the file in the chat. Just a second. Can you see it in the chat?
Uh,
Yes.
yes, we can see it.
Okay, great. So yeah, so one of you maybe can, yeah, I think Ajit has also joined. Ajit, are you in the room now? If the prompt questions are not there, I'll share the prompt questions as well in the chat. Anyone from this room, Ria or Ramesh sir, Pradeep, anyone, would you like to be the scriber? If you can open and share your presentation. Share the presentation
Sure.
and then everyone can jot down the
Okay.
points.
I will share my presentation.
Okay,
Fine.
great. Great.
Stuti, sorry to interrupt.
Hey, hi, Pradeep. Yeah.
I have just joined.
Sure,
I was in
Pradeep.
another meeting.
Yeah.
Exercise
Yeah.
means what we have to do.
Yeah, no problem. So, so there's a file I have dropped in the chat. It's for the first breakout. So essentially, the idea is as a group, we have 10 more minutes. So as a group, we sort of jot down points. What's the benefit of systems engineering? What's your motivation? How systems engineering can be of help to you or your team? Okay. Let me see if I can allow you to. Okay, probably it doesn't allow me to select. Okay, then I will share
Yeah,
my
that's good.
screen.
Okay.
No problem. Okay, can you see my screen? Yeah.
Yes, I can see.
Yeah. So Pradeep, I put the questions also in the chat. So those are just pointers for you. I can, bring them up here as well. So as a team, see each one of you may be coming from different industry verticals, different domains. So in general, what brings you here? What you wish for systems engineering to solve for you? Where can systems engineering make a difference for your team, for yourself?
Okay.
It could be fuzzy. It could be
Okay. From my standpoint, what I see, systems engineering helps us, the entire team, to see the picture from end to end, how from concept to the end of this product, which is going to be used by end customers. Okay, end to end visualizations, virtual visualizations. That's what it helps. That's what my understanding is from systems engineering.
So from my side,
sure,
I would like to add that it helps in breaking down the complexity, and it helps in building like modular subsystems. So when you have the entire system view, then you know that what subsystems go in, and then you can also have the plug and play type of subsystems.
And from my side, when there are interdisciplinary systems, or when we have to work within teams, interdisciplinary teams, then systems engineering helps.
Helps with disciplinary teams. You mean discussions? You mean development? What would you like to point out here?
When there is a complex project, we have interdisciplinary teams involved in that same project. So systems engineering approach helps to simplify that communication, or we can say visibility also.
Communication, visibility. Does that capture your point? And Ria, does your points are captured?
Yes, they are.
Venkatesh, you just
question,
joined. Yeah, sorry, go ahead.
One question from my side, since I come
Yes,
from IT background,
right.
how does this fit into the agile methodologies? Does it really help, or is it completely opposite of the agile and the systems engineering? I don't know. That is not a benefit. That's just a question for
Sure.
clarification.
This question comes up often. It's not unknown.
Okay. Okay.
So I don't know if anyone from this group would like to answer. I know a few participants are from software background. Would anyone would like to add their perspective to it before I share mine?
Because I'll tell you why these questions keeps coming. Because systems engineering, LCA, I just take an example of LCA, what HCL did. It took 40 years, okay,
Right,
from
right,
concept to birth to usage in the military. It took 40 years. When
right.
I started my career, it was already in the almost 30 years back. I used to visit HCL for some other projects, and I used to hear a LCA that it's already 10-15 years in the pipeline. So, how can is this like because of the way that it is being handled, or it is the way this entire waterfall methodology of the entire systems engineering has took us so much time? I don't know.
Yeah. I think LCA, Ramesh sir, there were a lot of unknowns when LCA was developing. There was a lot of
Right,
technology that was still under development. So I don't take
right,
that as yes, it is a complex system development, but may not be the best example as a reference.
right, right.
Like, probably when they started development, there was no concept of, or there was no availability of wind tunnels, right? So it takes time to
Right, right,
build those supporting systems
right,
as well.
right,
To your question on agile, it's a way of doing thing, right? When we are looking at these points, like how to create visualization, how to break down complexity, and how to look at building modular subsystems, all of these design activities, development activities can take agile format. I see it that
okay,
way,
okay,
because agile brings in its ceremonies, it brings in a way of doing things, whereas when you're looking at from the systems engineering lens, you are more gearing it towards the development, the technical development of the system itself.
okay.
And that's my personal perspective, but anyone in the group would like to add, or would you like to add more benefits that you see, or you hope that systems engineering should solve for you? It may not be available today, but you hope it should take you there.
So I would just like to add to what you said, Stuti. So I was part of INCOSE conference where there was a debate around we or not we,
Right.
whether we should follow the V life cycle or we should switch to a agile methodology. I think from coming from automotive background, I feel like V is not going away, but within V, we can have small agile life cycles and adapt the methods of agile in each of those stages
I
to
think
make it faster.
that's a very nice way to put it. Ramesh sir, that works.
Yes, yeah, that works actually.
Yeah, I think very well answered. Yeah, thanks for sharing. Anyone else? Anurag, you just joined. Venkatesh, you also joined when the group had already started. So we are just jotting down points from your perspective, from where you stand at in the organization. These are probing questions to essentially, why do we need systems engineering? So feel free to chime in. Paras.
Hello, I'm Paras, and I'm a student, so I'm studying systems engineering. And what we study is implementation of automation ML. And I believe that we are using systems engineering because at each stage there is some loss of data when we move from, let's say, blueprints to implementations and all that. So I believe that systems engineering helps in prevention of that loss of data interdisciplinary.
Okay, loss of data. Yeah. Thanks for sharing.
I would like to answer for the next question, which is what I wish for system engineering to solve. Which is, so I think it was touched upon a bit that there is model-based development, and model-based development aspect of system engineering, I wish for it to solve, let's say, or help in the better communication, or basically be on the same page when we are going from architecture to development to testing. If we have everything which is model based, then it helps with traceability. It helps with so traceability in terms of the allocation, and it also helps in terms of breaking down the complexity, which was my earlier point.
Okay. Does that capture, Ria?
Yes.
Okay, great. So I think the other rooms are also done. So we'll close the room, go back to the main room. One of you, Ria or Ramesh sir, would you like to just summarize the points from this room?
Sure, I would like to. Yeah.
Okay, thanks,
thank
Ramesh sir. Yeah. Yeah. Okay, so I'm closing the breakout room. See you all in the main room.
You will share the screen there also, right?
Yes, and Deva also has
Okay.
access. This is in our cloud,
Okay.
so
Okay.
he should be able to open. So,
Okay.
all right, thanks. See you in the main room.
Okay, I think we are all back from the breakout rooms. I just have a quick check.
Yes, room 3 is back.
Okay. So maybe we'll take a few minutes to discuss all the 3 rooms, and let's start with room 1. So I think room 1 was the one where I was, right?
Yes.
Yeah. Okay. So I'll be sharing the screen, but I would request anyone from my team to come up and just walk through the points. I think that will be great. So let me quickly share the screen.
With it, a few could not make it into the breakout rooms. So yeah, maybe just help establish what we did there briefly.
Okay, sure, we'll do. Okay, so I'm sharing my screen now, and just for a quick recap, we went into the breakout rooms and we were discussing what are some benefits of system engineering that we seek, right? So why do we really need systems engineering? And we actually came up with a good list of some benefits, and maybe someone from a team would like to go ahead. Sorry, we were not able to decide on who's going to present. Otherwise,
maybe you go. I can jump in, but then
okay,
start.
sure.
We'll get a few others, right?
Okay.
So really, the first point was to understand and break down complexity, depending on whatever the level was, the program, project, etc. And that led to a whole heap of other points. As a result of that, we're better able to manage risks. And when we understand the risks, you can then understand where to focus effort and energy in the project, in terms of the life cycle, in terms of wherever it might be. The need or the benefit of systems engineering is, start with understanding what the need is in terms of user requirements and translating that into system requirements and providing a mapping from that need into system requirements into actual capability definition. And what that means is it improves the ability to set out a complete and consistent solution, and we minimize the gaps and missing out on requirements. There was other points further down where we talked about that same concept in a whole of life and a systemic view, as opposed to just thinking about the technology. So as a result of that, we maximize our chances of building the right solution. And we also then understand that from a whole of life perspective in terms of change management and how we optimally come up with that definition. So maybe I'll step back there with it. Maybe someone else jumps in for some of the other ones. Yeah.
Sure, thanks, JB. Then we had a few points over communication. So helping us improve communication between various stakeholders. So it's also a challenge that many of us face. And looking at bringing all the stakeholders under one roof. Okay, so maybe I captured that thrice. So, and then also looking at understanding the interdisciplinary sort of dependencies. So these are dependencies that are cutting across the various domains and disciplines, and also across various systems. There were a few more points that came up. So identifying the right stakeholders, and system engineering is going to help in this. Identifying the right SMEs. So this goes back to sort of the planning activity. And another point on SME that came up was that today SMEs might be working in silos. We'll have a better understanding of bringing them together. Yeah, I think the rest of the point already covered. So that's all from our group. Maybe I'll ask Deva or Stuti to share. Stop share. Ajit.
Yeah, I think room 2 can go, and I believe someone else from Ajit's room is going to share.
Okay.
Yeah, can Deva or Mudit, can you open the file from the folder? And Ramesh sir will be.
Okay. Mudit, will you?
Yeah.
Okay.
Yeah. So I should open Ajit's file,
Yes.
Right.
Yep.
For
breakout room 1.
Breakout room 1, Ajit. I'll go ahead and share.
Thanks.
Okay. Yeah. Thank you. Hey, thank you, Stuti, for facilitating the team. So Mudit, we have come out with less points compared to your team, but still our team was very active. Some were actively speaking, and some were actively listening also. So both kinds of team members were there. And we spent good amount of time on agile and systems engineering, and what Deva gave one example of LCA, which took 40 years to develop and all that. Was it because of systems engineering, or is it because of some other problems and all that? Okay, but many of the points which Mudit you mentioned from your breakout room and ours, many are similar. I will not go again; those things will not just to save the time. But really, if you really see, it helps systems engineering to see end to end for entire team to see from concept to the end product, and then break down in complexities so that it can be managed easily and developed, and interconnections, all that kind of things, like interdisciplinary of everything, either it's communication or development, and all those kind of things. And the team also discussed about MBSE to allow meta communication, traceability, allocations, and all these kind of things. Okay, so yeah, looks like Mudit, your team and our team, many points were same, but
okay,
we came out with less. Yeah, here, but we had some good discussions on two areas. Yeah.
Sure.
Stuti, hope I covered all the points. Or if there's anything else, you can add additional points.
Oh, good, sir. Yeah. Anyone else from the team, if they want to add, they can add. But I think you covered it well. Thank you.
Thank you.
Thank you, Ramesh sir.
Thank you.
Okay, so let me show what seem to have lost my okay, seem to have just facing some challenges. Let me get back. I'm not able to see the file that I opened and was working on. So just give me a minute.
Sure. Do you want me to try?
No, I captured all of them in a file, but now I'm not able to see where that file is.
One way, Deva, maybe if you open PowerPoint and go to File and open it to give you recent files.
Bringing that time.
Yeah.
No, seem to have lost it. I'll give it one last try. Yes, now I can see it. Okay, so yeah, sorry about that glitch. So we went around the room and I kind of noted down who shared what. So again, a lot of things that we talked about. There were things like Avinash was talking about the elephant metaphor of blind people standing around an elephant, each see their own things, similar to the SMEs and silos that you were talking about, how to have a holistic perspective. A lot of things came in terms of early realization, doing things before early on, so that you can avoid cost and time for rework, avoid reiterations. Development cost and time can be optimized. So these were things that came out from a number of our participants here. And the complexity also came in. JB was talking about complexity. So similarly, how systems engineering can help solve complex problems, can reduce development time, early detection of defects. And Akshay also mentioned, can get cost savings up to 30%. And Neha was talking about how verification can be done at an early stage itself, so that you don't realize errors too late. You're doing it much early. So yeah, so I think there are common themes across the rooms, but this is what we had discussed, Mudit.
Thanks, Deva. So I guess a few things to ponder or consider here is, now, do these benefits actually match with the context of system engineering implementation? And we didn't have too much discussion around this, I guess, in the room, but maybe it can be a question. Whatever thoughts that came to mind while looking at how would system engineering realize some benefits in your organization. Also do consider whether this will fit into the context of where you started from. So going back to step one at this point, for example, if I'm looking at realizing some cost benefits, probably that scope, you can now scope it out to whether making those cost benefits are in your hand or they go beyond your organization. And to what extent can you negotiate those boundaries, right? So it gives you a realistic idea of what is possible, what is not feasible, and what can be negotiated. And then also the second point then is putting some metric on it. So sort of quantifying these qualitative objectives of yours, which is, can these expected benefits be quantified or measured? And of course, measuring these benefits would actually make sure that you are on the progress or on the right track. And then, of course, is there a baseline to establish the current levels? So baseline can come from the history of the organization. Maybe you're already having some other changes in the past. You can look at those. The baselines could be based on the metrics that you have been tracking in the point number 2. And you can also do some benchmarking along with to look out in the academia or with other industries. So I think with that, I will hand over back to Deva.
Yeah, thank you, Mudit. So just to continue the thread that Mudit was talking about here, it's important for us to establish a baseline in some way, because let's say all these benefits we talked about in each of these rooms, we identified a number of benefits. How will you know that you have actually realized those benefits? How can you say that systems engineering helped you? How much rework are you currently doing today that you're going to reduce tomorrow? So unless you establish some form of a baseline, how can you show that there has been a benefit, there has been an advantage? Cost savings, to say that 30% was cost savings that was realized, 30% with respect to what? When we talk about early detection of errors, are we talking about, again, going back to the context within the organization with it, what you're doing? Or is it something that is going to happen in another organization when it goes into the manufacturing unit, when it goes into an organization that is doing the actual maintenance and support? That is where some of these can be measured. So how can we bring those metrics here? How can we measure here? And what is the current state? This is actually a challenge for the entire discipline of systems engineering at large. When someone who is not familiar with systems engineering, or someone who is even skeptical about systems engineering, talks, what great benefit can systems engineering give me? It becomes a very difficult answer when we don't have quantified measures or metrics. Okay, so that is something to keep in mind. So as we are talking about why, remember that someone else is going to hold it back to you and say, you said these were the benefits that systems engineering is going to provide. Show me how it is going to, how is that benefit going to come out? Can you prove it to me? Right? So those things we must start thinking about, and before we get into the further aspects of the implementation. Okay, so keep that in mind. And we have finished the where we set the context. We have identified the why, listed out things, but this is where we need to be realistic. We cannot be over ambitious. There are things that we may want to do, desire to do, but is it feasible within the context of where we can implement systems engineering? So that is a reality check. So we need to go past the why step with a realistic list of this is what I want to achieve. So my systems engineering implementation is going to help me in these very specific things. So we should have a realistic, reasonable, feasible list that we go ahead. So in some sense, it's like requirements, right? So we talk about good characteristics of good requirements, that, it must be verifiable, feasible, correct, simple, and all those things, singular, and all of those things. So it is something like that. So when you're talking about benefits that you want to get out of systems engineering, let's be clear about it. As systems engineers, let's be clear about it so that we can proceed and see where exactly how these can actually be realized. Okay, so we are moving on to step 3, and here is where this is a list of processes from the INCOSE Systems Engineering Handbook, and 15288 has a similar list as well. So if you look into the handbook, these processes are under 4 different categories. There are technical processes which are related to the system. There are technical management processes which are related to the project. There are agreement and organizational project enabling processes which are more at the organizational level. So even within the handbook and these processes, there are 3 categories. So remember that we talked about the very same differentiation during our context setting as well. So when we talked about where we want to get benefits from systems engineering, is it in the system level, project level, organization level? So step 2, when we looked at these are the specific benefits I want, which processes are going to give you that? Is it going to be a technical process? Is it going to be a project process? Is it going to be an organizational process? So that is something to really think about and map and identify what is it that needs to be done. So here we are talking about what systems engineering activities will be needed. So we're talking about the what here, but we need to go back and look at it. So again, as part of the webinar, we are just flowing through these steps, but you can imagine that each of this is going to be an involved process to identify what processes will be relevant to achieve your goals of why systems engineering that you can implement within the context that you identify in step 1. This is going to be an involved process. So at a high level, if you're going to look at something about V&V, you're talking about stakeholders, you're going to pick out those processes. You're talking about anything to do with risk. I saw risk in some of the, maybe in room 1. So if you're talking about risk, you're going to look at risk management processes, and that is a project related processes. It is not something that you do as part of your system lifecycle model. So all these things you need to clarify, you need to make sure. So what you do at this stage is, you pick the processes that are relevant based on your implementation context and that are relevant to the expected benefits that you have identified in the previous steps. So here, this activity can be at a very high level, or you can go into the detail of very specific activities and sub-activities that need to be performed. The INCOSE handbook is a good starting point. The list of processes that I showed in the previous slide is a good starting point. But there again, that's where the tailoring aspect also comes in. You have to look at it and see in the context of your system, your project, your organization, which are the activities to be performed. So when you finish up with step 3, you have a reasonable list of activities, of systems engineering activities that you wish to perform, but they are directly related to the benefits that you draw from it, and vice versa. So which means if you are expecting a benefit and if you're doing nothing about it, how can you get that benefit, right? So those kinds of mappings can be done. You can ensure that all the benefits that you are looking for can be realized when you adopt these, when you perform these activities, and all of these are feasible given the context that you're working on. Okay, so all this is good where we are identifying the what. So now we go to the next step. Okay, the next step of who will perform these activities. So we have a list of activities and we have a reason for having that list, but who will perform these activities? Now, this is another big challenge for organizations, especially those that are trying to get into systems engineering, who are still not very mature. This is probably the first or one of the few projects that they have where they're trying to bring in systems engineering. So this is going to be a challenge for such organizations. It does not mean that there is no challenge for organizations that have been doing systems engineering for a long time. But this is an important step, because once you identify activities, you need people to perform those activities. Who will that be? From the registrations that we got, these are the various titles that are there. Okay, so there's program manager, project engineer. You may find your title here, you may not. It's not an exhaustive list. You have lead engineer, operations head, requirements engineer, assistant manager, you name it, senior architect. All of these things are there. Okay, so all of these job titles, how is it easy? Is it easy or not to find out who is a systems engineer, right? So who will be performing systems engineering? It is not very easy here, and depending on where you are in the system level or in the organization, this is a view from a requirements point of view. But still, if you look down the left, you will have various levels of engineers who are dealing with various levels of requirements, and thereby various levels of the system. So there are component engineers who would look at component requirements that come to them from the higher level subsystem, and they could be at a very different organization, right? So you could have system engineers at the top level who are interacting with stakeholders. Someone who is at a disciplinary level need not have an opportunity to directly interact with stakeholders. So where you are in this hierarchy of, in some sense, whether it is in the same organization or outside of or in different organizations, all of these things matter. And who is the one that is performing systems engineering? Is it only the one who is there up top, who is interacting with stakeholders? What about others? All these are questions that need to be asked in the organization and in terms of who is performing systems engineering. Okay, so with this, we're going to do another small activity, and I'm going to bring back Mudit to describe to us what are we going to do.
Okay, so like the previous exercise, we'll be now taking about 10 minutes for this breakout, and we'll be asking the question around who's going to perform the system engineering in your organization. So even many established organizations who've been sort of practicing system engineering for many years now, I have seen they still do not have like formal roles or formal roles defined for system engineers. It is often sort of a mixed responsibility of many roles. But barring that, maybe here we want to think about your organization. So you can think internally, what are those titles, what are those designations that you would like for your system engineering implementation? And then what are some system engineering activities that they'll be performing, right? So also, maybe is there a team that performs system engineering collectively? So there are, sometimes teams meant for requirements management, sometimes meant for MBSE adoption or for some other activity. So those are the three questions that we would like to get answered. And maybe now we can move to our independent breaking groups.
Hi, back. So, let's see. All right, over to you, team.
So in my organization, we do have a system engineering team who will take care of the discussion with the stakeholders and a write-up of the system requirements and building the system architecture.
Requirements, architecture.
And basically also requirements, either the user requirements. So discussion with the stakeholders also happens as part of that. And then a writing of the requirements which are specific to, yeah, like system requirements basically. And then they would also help in the system analysis.
Okay. When you say system analysis, is this like low
Like
fidelity
system
models?
FMEA.
Okay. Okay.
Any designations roles? Because I don't know much about that. I'm just asking for that. Okay. If there must be some existing, right? Like the way Agile has, the way other models
Right. So
also
they
have.
would be called as like system architect or system requirement engineer and so on and so forth. But collectively, they would be under system engineering organization.
Okay.
You have requirements. What did you say? Requirements engineer?
Yes, requirements engineer.
Okay. Just a second. Yeah. Anyone else? So I think from what Deva was sharing, maybe those roles are performed, but they are probably called as technical leads or technical architects, and that's also fine. So if you're able to identify roles that way.
The stakeholder communication, who does, like either it is to the team and to the management and to the with the customers, who does that and how they do it? Is something like that also there in the SE team? Like stakeholder communication.
Is it a question for Ria? Is that a question
for anyone?
For anyone, okay.
Sorry, I missed the question.
Like a stakeholder communication, like a communication within the team, communication to the management, communication to the customer, something like that. Any role is there, and then how they do it actually.
Yes. So when I said requirement engineer, they would be communicating with the customers, get their requirements, and then internally they would write requirements and pass it on to the subsystem teams.
Okay. So like customer will tell, okay, I want a plane like this. Okay. So then he will tell only this much. He is not going to tell the total technical things. Okay. Then the requirement engineer understands that and then designs it to the technical specifications and then communicates to the team, right? That's how it happens.
Correct. Yeah.
Okay.
How about you, Paris? Do you have a SE team or anyone playing systems engineering role in your organization?
Actually, I'm a student, so I have no experience in this field.
Okay, excellent. So you're going to absorb everything today. So then
we all are learning from each other. So we are learning from each other.
Right, right. And Anurag is part of Blue Kai team, so he's a
Okay.
system engineer.
Yeah.
NBSC engineer.
Right.
Ramesh sir, how about you in the startup?
No, we don't have any. No.
You're doing all the roles, isn't
All
it?
the roles, and we have a team members, but we have a technical specialist. They talk to our business analyst. They talk to customers, understand the requirement, then convert into the technical specifications for our developers, and they design the solution. Actually, that is how it happens.
Mm. Okay. So
ours is not as of now. We are not a systems engineers. We are a very startup. So we multiple teams are members are taking a multiple roles. But yes,
correct.
business analyst to technical specifications to developers. That is how it happens.
Mm-hmm. Amit has just joined. Amit, I think earlier you were having some challenge in joining. So we are just discussing in your organization or team who performs SC activities. So you can see two discussions jotted there. Would you like to contribute anything?
Yeah, actually, we have one systems engineering group newly formed in my organization. Okay, and but the manpower is very less. We are very few people, 2 to 3 people only. So as of now, what we are doing is we are capturing requirements from the user. And one additional task was given to us is that we have to adopt model-based systems engineering approach in our organization. So towards that, we have procured some tools and got some training also from the vendor.
Okay.
So we are on that path now.
Okay. So when you say user requirements, do you mean to say digitizing them and is somebody else writing, or your team is writing the requirements also?
No, user requirement. They have given some requirements in document format.
Okay.
And we are using some requirements tool like doors now. So we are using that software. And those user requirements we are again rewriting in a detailed format.
Okay.
In a form of derived requirements.
Okay. Okay.
That additional work we are doing.
Sure. Sure.
I think there was one more person, Uma, who probably left, right?
Okay. Yeah, some are having challenge to join the rooms. I think ours is the room which has maximum challenge. Okay, Ajit has made it, I think.
Finally, yeah.
So Ajit, you can give your inputs. You have a lot of experience.
Sir. सर आप हैं सर
अरे नहीं रे भाई हम तो सीख रहे हैं आप लोगों के साथ सीख रहे हैं हम लोग
Okay, yeah, so where are we, what all you're looking at?
So you can see 3 inputs that came from this group, yeah, and we have the last minute also, so maybe we can close the discussion. So we are trying to jot down what sort of team or team composition or titles are there and what they do. So
okay.
Inco, is it telling anything? Let's say this has to be the ideal way, or no?
I think Deva has a slide on that.
Okay.
Yeah.
Yeah, but you can even put in your thoughts, ma'am, as what really could help your organization from your perspective.
Hi Ajit, this is Ria. I've given my input.
Hi Ria. Hi Ria.
You don't have to tell me, ma'am.
Okay.
I think
anything for just a quick one, anything on the verification validation? Do you see that in the group? I just want to challenge is that something?
Actually, I forgot to mention, we also had that as part of system engineering. We'd have system integration and system validation.
So are they given some title like verification champions or just engineers?
No, they do have integration as part of their title.
Title, okay.
Yeah.
Interesting. Okay.
I see a lot of similarity because we use mostly CMI model, okay, development or a services model. So I see a lot of similarities between that and this also, engineers. Yeah.
Sure, sir. Yeah, sure. Yeah, and then different roles and different responsibilities do overlap. Yeah,
right. Yeah.
Correct.
All right. Thank you, everyone. See you back in the main room.
Sure. Yeah, thank you.
Sure. Thanks.
Okay. So maybe
we're back.
We're back. So I'll just get started by sharing. Okay. So we end up taking always a second sheet. So shall we get started, Deva?
Yeah, I think so. Yeah, I think it's
okay. So of course, the first one that came to our mind was requirements engineer, and we thought about please feel free to add. So we had requirements engineering, and then there we thought, could there be specializations under requirements engineering also? So someone who's looking at functional, like the traditional way of looking at requirements, so functional and non-functional requirements, and then more focused on entities. And then another one were like very, very specialized roles. And that's where we were also jumping back and forth between, cybersecurity or safety. And we also looked at human factors and user experience as coming as new dimensions.
Mudit, I have a question. What is ELITES?
ELITES stands for all the things like safety, manufacturability, security, all these terms that are qualitative in nature and very specialized in nature. So those are the ELITES. So that is what we were talking about here.
Typically reliability, maintainability, supportability, modifiability, all the ELITES.
Right. So yeah, and JB would like to add anything else here?
That's good. Keep it with it. Do a great job. Thanks.
Okay, and then the other one came from sort of the program management perspective, which was looking at requirements at the high level, and I think it was also coming from the idea of acquisition and supply. Another one that came from was in the terms of if the organization is following agile methodology, then you have some role as product owner. And we were trying to draw parallel to teams that are not following agile. They would have someone as a lead system engineer or chief system engineer who's going to be the face of the customer, and they'll be responsible to maximize the usefulness of the product. Then few other traditional ones like, of course, the V&V engineer and the system architect. We thought that V&V engineer could also be a team, depending upon the complexity, the domain of the technology and what phase of the technology you are in. It can become a large team. And then system architect, and maybe a few more were some digital engineering experts, so such as people who are very much conversant with the tools. They are not thinking too much about the methodology, but more focused on the tools, like capturing models, doing requirements capturing within the tool, or looking at CAD geometry design, etc. And then, of course, cybersecurity came up multiple times, and human factors. So those were a quick overview. Over to you. Is
room 2?
Should I share or?
So Ajit was Tuti. Can you? So yeah, just open up the breakout room to Ajit and see.
Okay. Give me 1 second.
Yeah, but it's on the drive. You can open up.
Okay. Yep, I got it. So sharing again.
Ria, do you want to talk through this one, please?
Sure. So we had multiple people pitching in for different types of designations and titles they have within their organization. So the first one was my own company, where we have a system engineering team. They include the system architects, requirement engineer, and also the system integration and system validation. So with the titles, respective roles are that they would write, basically they would communicate the requirements to the internal team after getting the user requirements. The architects would build the architecture, and they would also be part of the system analysis, like system fault tree and system failure mode effect and analysis. Then in other set of organization, the business analysts play the role of similar to requirement engineer, wherein they get the user requirements and derive system or technical requirements. The third, it's a very small system engineering team, wherein they capture or gather the user requirements and adopt it to the model-based system engineering approach. And basically the last one is part of the first SE team. Yeah, that's all. Anybody wants to add from group 2?
Thanks, Ria.
Thank you, Ria. Yep.
All right, so let me share what we talked about in room 3. So in room 3, again, we went around the room and we had about 4 or 5 talking about how it is done in their own organizations. So Prasad was talking about how they have a very well-established systems engineering group with designations like manager, lead systems engineer, senior systems engineer, lead systems engineer, and some are associated with the project. A lead systems engineer would look at multiple programs, improve SE process across the whole. So a very well laid out large kind of a SE organization. Sharad talked about one group which looked at 3 aspects: the design system, the application systems, and the MBSE, each having their own areas of work, but designations like systems engineer, designer, principal systems engineer, manager. That's how Sharad's organization was. Avinash was talking about a recently formed SE group, still maturing, but there is a one group, and they do requirements. They have designations like lead systems engineer. They do system start level analysis. They bring in SMEs as needed. So that's what Avinash talked about. And Neha talked about, again, there are no strict hierarchical roles like other well-established organizations. This is more of a research organization. So they have, and they're adopting MBSE. So they're talking about model-based systems engineer, lead model-based systems engineer, and they do MBSE artifacts, system level artifacts, behavioral simulations, diagrams, and things like that. So what we did was more about trying to capture what was there in organizations. And so, yeah, so I'll hand it back to you, Mudit, and then we can.
Sure, Deva. We can, share the. Okay. So maybe you can go to the next slide.
Yeah. So do you want to summarize in any way?
No, I think we are good.
Okay.
So.
All right. Okay. All right. Thank you, Mudit. So thank you all. I think as part of our discussions, a number of things came out in terms of maybe we are looking at what other organizations are doing. We're thinking about what we need to do and all of that. A broader question that is there, that is asked in many organizations that are doing systems engineering, or organizations who are trying to get into systems engineering. The question is, who are systems engineers? Okay, so that's a high level question. You can ask this question for many other disciplinary engineers as well, and some questions may work there. For example, can you say that systems engineers are those who have a systems engineering degree or a certification? The answer is no. for systems engineering? Is it those who have systems engineer in their titles? Again, the answer is no, because when you look at systems engineering, and it has its origins in aerospace defense programs in the US in the 1950s, 60s, and 70s. And so even if you go to some well-established systems engineering organizations, you would find that almost all of the senior systems engineers, they do not have a systems engineering title. There are organizations where systems engineer is never in the title. So how do you identify systems engineers, right? So the approach that Incosi takes and many of us take is that systems engineers are those who perform one or more of these roles. Okay, so there is a famous paper from Sarah Sheard a few years ago. Then we recently revised it, and there's an updated version as well. So this is one better way of identifying who are systems engineers. They could have a role that is focused on the system. They could be doing things related to the team. So an organizational position or a title or a designation is typically a combination of one or more of these roles. So you can have a title that says whatever. It could say systems engineer, it could need not have systems engineer, it could be something else. But the whole idea is what are they performing in that role? Okay, so that is what is important. And so when you look at it from that point of view, there is also the question about what should systems engineers be good at? Okay, so as part of a study that I did, we have done this. When I was in the US, I did this. So there are a number of things we can talk about in terms of competency areas and competencies they need to be good at. So we can kind of define systems engineers and say whether we give them a title or not, whether we form them into a group or not, what they need to be good or that they need to be good at. All these things are there. But coming back to our question of where we are in our systems engineering implementation process, and here we are at the who will be doing systems engineering, who will be performing systems engineering activities. We have already crossed through 3 steps. So here the question to be asked is, do we have the right persons to perform all the required systems engineering activities? So in the previous step, we had listed down what activities were needed to be performed. Do we have the people? And the other thing is to do all the required activities. We cannot again leave gaps here. Now, the other thing is whether they are going to be formed as, are they going to be individuals? Will they be performing out of their own respective groups? Will they be pulled out and gathered into another team? In any of this, there should be clarity. So individually, are their roles and responsibilities clearly defined? If they are formed into a team, is there a clear definition of as a team, their responsibilities and authorities are with relative to the org structure? So here again, there is no right, wrong way. It doesn't mean that the SE team should be the one that has all the required competencies to perform all the activities. You could have separate teams. MBSE, should it be within the SE team, or is there a separate MBSE group? Or is it that whoever is doing modeling simulation, they do a little bit of MBSE related work as well? So all of that matters. So we have to go back to the context. You have to go back to how your organization is, and the roles. The big overlap is between project manager and systems engineer when you look at it from a systems engineering point of view. Are these roles clearly distinguished? And each organization takes time to find this balance. It also depends on what role existed previously and what is the new role. So in many cases, project manager is a role that was already there. Systems engineer may be a new role. So who reports to whom? Who does what? All those things matter. A major difference between the perspective of project manager and systems engineer is that, remember, in the context we talked about an organization, a scope, and the project. Within that scope of, you may be doing a design development organization and are doing a feasibility study, that coming up with a new concept for an application is maybe the only project. The project engineer looks at the start and end of the project. So there is time, budget, schedule, all of that is being looked at from the project point of view. But when you look at it from the systems engineer's point of view, a systems engineer who is sitting as part of a conceptual development team, that systems engineer has to still look at the entire life of the system. Okay, so project manager will not look at that. So this is where some of the conflicts and overlaps come. So these things have to be very clearly identified. So it is important to have the right people to perform all the activities, and clarity in terms of what their roles and responsibilities are. And organizations that are getting into it, you can always start it. There could be some change required. You need to look at the dynamics, think ahead, make modifications. All that is there. You learn from experience. But the underlying fact is that you must have a clearly defined group, individually and collectively, to perform all the systems engineering activities that you have recognized. Okay, so that you have identified. So that brings us to the next step, which is the how. So we went from the where, why, and what, and who will do the what is what we saw earlier. Now we are getting into how will systems engineering activities be performed. Again, as I mentioned, we are kind of breezing through these 6 steps. Each of these steps, when you really want to get into implementation, systems engineering implementation, will be a very involved step. A lot of work has to be done. So talking about this, we are again looking at now how. So who has been identified, but how will they be doing it, right? So that's where things like tools, methods, processes come into play. Maybe again, I'm going to hand it back to Mudit to walk us through another exercise. This is, we're not going to go into breakout rooms.
Right.
It will be done as a pool. So yeah, yes, Mudit.
So we'll be getting actually a link for the categories of tools. And here we need to really think from the digital engineering perspective, or if you are not using any specific system engineering tool, whatever tool you're using for different activities. So try to think of those. For example, from different phases of the system engineering perspective, right? We looked at the various roles and responsibilities. So what are those roles? How are those roles performing their duties? What tools are they using? So we can think about all of those, and we would like you to do a quick poll and fill out all the tools that you are using. And if the category is not listed, feel free to add them into the other, or you can use chat also to add. But I think we are going to get a link for this poll. So it's a multiple choice poll. So please see if you can, if you're using multiple of those, you can add them. And also if the tool category is not in this list, if you're answering others, feel free to use the chat to add more details. So I see we already have 2 others in the poll. I would encourage you to add them into the chat. Okay. So 80% have already participated. Others, would you like to add them? Okay, so it's not changing. Okay, I think we can, I'll just summarize it quickly. So basically we have requirements management that is sort of lead. Probably it's the most common type of tool that is used. And then the next one is MBSE. And so PLM, ALM, and then simulation lifecycle manager, we have just one. Maybe I would like to add few things. So Sometimes ALM is more coming from the software perspective, but then requirements management also gets counted in ALM. So sometimes you'll see an overlap between these two. The simulation lifecycle manager is more coming in these days, where you try to manage the lifecycle of the simulation. So, and then interoperability tools, such as tools that are working to bridge the different type of tools, such as bridging the requirements management with MBSC or with PLM. And then we have Prasad. He's mentioning technical risk management tools like DFME, FT, etc. So thanks, Prasad, for adding that. I think we can end the poll now. So it's a good overview. Okay. Sure. I think back to you, Devardhan.
Yeah, thank you, Madhut. So we just wanted to get a feel for what systems engineering tools are being used in your organization, or probably you are considering purchasing one. But this is where we want to tie it with our implementation process, right? So we are in step 5. And we are talking about how will SE activities be performed. The thing is, do we have the resources needed to perform the activities that we identified in step 3? So consistently we keep going back. We keep going back and saying, okay, this is why we wanted to do, this is what we want to do, and this is how we will do it. So the resources tools is just one of it. It could be methods, processes, infrastructure, enabling systems. There are all these things that would be required to perform. So the who to perform has been identified as well. But let's say requirements engineer is a role that you have identified because you want to do some requirements traceability, and that will help you reduce your rework. It could help you identify early detection of errors, all of that, right? So, but when you come to this stage, you have a requirements engineer as a role you have identified. You need a tool. Gone are the days when you may have done it in documents or Excel. You need a tool now. So is that tool ready? Is that available? Is it ready to implement? Can you just buy it and start using it? There is an element of installation where compatibility of the resources of your IT infrastructure from the requirements tool, where is information going? Is that compatibility established? Is there an aspect of customization? Is there an aspect of training the personnel before tools can be ready to use? So all these things have to be thought about, right? So that is where, again, we have identified this as a explicit step where you are thinking about how you will be performing the SE activities. And that is where a lot of time can go into this. There was a comment earlier on, I think from Mr. Ramesh, about the LCA program and the time it has taken and all of that. Very, very commonly asked question that we have to face. But that is where the challenge is, because when we are doing something for the very first time, the infrastructure does not exist. Okay, so to give you an example, we have to set up a facility to do lightning test. Okay, a lightning test facility had to be set up so that we can qualify the fighter aircraft to say it is all weather. And the lightning test facility does not exist. So the time, effort to set that up, the time and effort to set up other components, some simple things like landing gear lights. There was nobody in India who could do that. And so to identify potential suppliers, set up the facilities, bring it up. So all these come into play. But once you have set up for the next fighter aircraft program, your LTF lightning test facility is already there. Your supply chain for getting landing gear lights is already there. Just to give you an example. So you need to think about enabling systems. You need to think about everything that you need to be performing your activities. If you want to do integration, you are doing if it's software based, it's different. If it's an Ironbird kind of a facility or hardware in the loop, model in the loop, do we have the facilities to do that? How long will it take to set those facilities up? And will they be ready in time when the system is ready for integration and it is coming for your verification, validation? So all these things, right? So how will you perform these activities? Do you have the resources? It is important to identify them and do it. Again, this is upfront effort. So you are thinking about your verification, validation, all of that, even before you are beginning your activities, so that when you reach that stage, you have what it's needed to do that. Okay, so we have crossed through 6 steps, and we are at the last step, which is where when will these be performed? So this is where the synchronization, time-based synchronization of all these come into play. You have identified things, but you have to lay it on a timeline and in a synchronized timeline of when what will happen in parallel, in sequence, what are the dependencies. And that is very critical for your systems engineering implementation. Okay, so given the who and the how, when can you really start, right? So you need to, when you start, you need to be able to go through your all your implementation activities. How long will it take to complete the required activities? Will this be able to meet schedule expectations? So this time synchronization is something that is very important. Many times we do not do this well enough, or we take it for granted, or our estimates are grossly wrong. We estimate this would take, typical to say man hours, right? It will take 100 man hours. And if I have 10 people, maybe, I can distribute it and get it done. I can put more people into it and can get it done in a week. All those kinds of things will come in. So this is where establishing a timeline really helps. And we really say that this is one of the last things that you would do before you actually start implementing. Okay, so just to conclude, we have gone through this kind of a 6-step implementation process, and we also indicated that there is some meaning in this sequence, why we recommend you to go through this. And this is not meant to be a waterfall, right? So we also saw that we keep going back. I didn't want to crowd this picture with too many arrows, but in theory, everything can go back to everything else, right? So at the time of how and who, you may realize that you're so reliant on an external agency to do it, and it was really outside the scope of your organization. And so you may want to go back and bring something inside of your organization. Okay, so sometimes acquisitions, mergers need not always be purely business decisions. There are technical decisions as well, that it is better to have that capability within yourself, and so that you can draw overall benefits. You see that a lot in supply chain as well, right? So why Walmart does well? Because they have a huge supply chain, everything is under them, versus some other organization that is outsourcing, and there is some level of efficiency that they can drive, but you cannot do otherwise, right? So all these things are part of it. So once you go through these 6 steps, what is it that we would recommend you to do is to prepare a implementation plan, okay, which is an elaboration of these 6 steps. Iterate, review the plan, and prepare it to the level of detail required. So at the very start, you need not have a very detailed plan, but you need to start somewhere. And you can use it for many purposes. You can use it for discussions with appropriate leadership if you are close to implementation. You can use this to initiate conversations. And this is something that you may do as an individual or as a team or with your immediate superior boss. It could be done in various levels, and you can set realistic expectations for a new project. You could also explore ongoing projects. How can we enhance it by looking at systems engineering? So all these things can be done. So theoretically, it will sound nice to start with a clean slate and start from the beginning and go through all of these. In reality, we all know that we are in the middle of project executions. We are not waiting for a new project to come in the future. We are in the middle of things. So in this, what can we do, and how can we think about systems engineering implementation for an upcoming project? So this is it is not just something that somebody can do as an individual or as an organization or a team. It's a mix of both. But again, think about this sequence, and also think about where implementation may have been the challenge for you. If you look back at this process chart that we have, where it may have been a challenge. So you would have tried some things, maybe did not work well. Where did you start wrong? It is very typical for organizations that you want to do, let's say, requirements engineering, to say, okay, we don't have a tool, let's go buy the tool, and then think about customizing the tool, then think about training the people for the tool, versus going back and doing all the pre-work leading up to buying the tool or procuring the tool, mindful of the time that it takes, and then make it as part of your implementation plan, and how all these things fit in. Your implementation of requirements engineering and a tool could be much better than starting it in a different way. Okay, so those are some of the things that you could do. And the whole idea is of this webinar is to get you start to think about implementation. So are you ready to begin thinking about implementation? And when you finish your implementation plan, that is again just the beginning of your actual implementation. So it is not that implementation is all done. And this is the message that we wanted to give you. It is not easy, and each of your individual experiences could be different. Some of you may have tried doing this. Some of you may have witnessed this being done in your organization, things that went well, things that did not go well. So here is an opportunity to think back, be realistic in your expectations, and try to follow some kind of an organized plan to do that. And it's not easy to do it. Sometimes you need internal help, you need external help. Internal help, you could go to people who have already done it, other projects who are maybe are doing it. Your project is not any of those scenarios. And when you look at external help, that's where people like us come in as well. So as Blue Sky, as an organization, we are here to assist you in number of things. And today we talked about systems engineering implementation. So whatever implementation related support you may need, we are available to help, support, discuss, and that can be scoped out as well. What could be the level of help that you need? What is it that you already have? And we'll be willing to do that. So on this note, I want to hand back to Mudit for some closing thoughts, Q&A, and other things that we'll do for the rest 15 minutes or so.
Okay. Thank you, Deva. And I think it was again a very good session with a lot of engagement and the breakout rooms. I would actually encourage all the participants, if you have any questions, you can now just turn on your mic and ask them. Or if it is not possible, you can always type them into the chat. We also have a feedback form that we would like to get filled. So maybe so I'll add that as well into the chat.
Hey Mudit, I have a quick question for Deva actually.
Sure.
Okay, so Deva, in your flow chart, Deva, you know where you had the what, how, why, and so was there a reason why you had the who, how, and when in parallel? Was there something in behind that was driving that? I might have missed it if you said it. Sorry.
No, maybe I did not make it explicit. So thank you for that question. They all spin off the what. They are all related to the what, but in some sense they can be done in parallel because there is a lot of iterations that happen between them. So when you look at the who and look at the how and look at the when, those are things that can go in parallel, very strongly interrelated, but all drawing off what. So it's not that you complete the who and then you move on to the how and then you move on to the when, even though there will be moving back and forth. These things kind of happen in parallel, and who is in some cases you already have things in place. How you already have some things in place as an organizational resource and things like that. So you kind of play with them in parallel. So that's the reason we had it in this way. But again.
I thought there was a subtlety to it, so thank you.
Yes. No, thank you for asking so that I could clarify. Thank you, Yuri.
So we had a question on the slides availability. I guess we have recorded the session and we'll be sharing the same. So the whole video will be available. And I've also shared the survey in the chat. So please do fill it out. And any question, any discussion that you would like to have, like if you want to share a specific instance of the effort that you have been doing in your organization, any challenge that you have been facing in implementing systems engineering, we can even discuss those right now. It doesn't have to be a direct question from the content that was shared, but it could be any specific challenge that you are facing, and we can have a good discussion right now.
I may add one more quick point, Deva and Budit. I think what you have also done in a sense today is created in a sense a framework or a reference architecture for organizational systems engineering, organizational architecting in a sense. Just as we apply systems engineering to create systems architectures for systems that we typically by default, are technological systems, but really it's the same concepts applied to create the organization itself in a sense. And so we see the forming for a reference architecture in that regard, and a framework that gives you these different perspectives to consider as you define the requirements and translate that requirement into an organizational systems engineering architecture. Any thoughts on that, Deva?
Thank you. Yeah, absolutely. So this could very well be a framework that we could that organizations could use. So that is kind of our strategic intent, but we wanted to start somewhere, and this is probably the first step towards that. So yeah, thank you for that note, JB.
Thanks, JB. I think that was very well summarizing the whole.
Yeah. So maybe as we are waiting, what I could add is that a kind of an underlying note which has not been explicitly stated here is the organizational awareness and acceptance of systems engineering. Okay, so there are organizations where there is resistance for bringing in systems engineering. A lot of questions asked about why systems engineering, and so there are many organizations that I've encountered where a small team, there is a systems engineering team that is doing some work. They really feel systems engineering can bring a lot of benefit to the organization at large, but the organization has been a very traditional organization, or they have been doing some things in a very different way. They are not so open to systems engineering, and to build the case for systems engineering is a big task. So being a systems engineering evangelist within an organization is a big task. So, but in those cases, thinking through implementation and coming up with a very realistic, achievable plan. So that's the whole idea of this whole process that we have discussed, is that at the end of it, it gives you a very comprehensive, consolidated implementation plan that you can take it to your organization and say that this is possible, and because we have thought through these things. And it's a very similar thing with the systems approach itself, right? So you do the upfront effort, you reduce the risk, you reduce the number of surprises, your success of the project or the system at large, there are higher chances of it. So similarly here, if we are bringing in systems engineering into an organization, trying to implement systems engineering, having a well thought out effort and leading into an implementation plan, the chances of successful implementation will also be higher. So that's another thing to look at in the context again of your organizations, how much of systems engineering is done at your organization level and things like that.
And we do have one question from Adele. So he asks, any experience with SE and CMMI? Would CMMI somehow help with the SE adoption? And feel free to add anything else you can add to this question.
I would like to add here, this is Ramesh here. Since we have been using CMMI extensively for development and services model, many of the roles or many of the processes I see very common, but looks like systems engineering is much more detailed for engineering product development than the CMMI is more focused for software development side actually. Okay, that's what I see as a major difference.
Yeah, Mudit, you wanted to respond or?
No, I think you can go ahead.
Okay, so yeah, you're right, Ramesh. There are things that some disciplines will bring in, like CMMI is there. You can have Six Sigma, you can have ISO. Various standards, various things are there, but what systems engineering, by definition, is a transdisciplinary approach, and it focuses on the system at large. So for individual disciplines, whatever works best it has to come in. So there is systems engineering accommodates all of that. And that's where, again, when we talked about what needs to be done, and who does it, there is an implicit thing about, is there an existing group that already does it, or should systems engineering start looking at it? If there are existing activities that are already done for software, there could be a very, very detailed software V&V expertise that you have built, tools that you have, and that would be fine. But from a systems point of view, is that all? What about software integrating with hardware? What about the system at large? So from a systems engineering perspective, where we see a lot of overlaps, when there is maturity that is already there in the organization, certainly make use of it. But where the gaps are in terms of taking it through the entire life cycle, thinking about all the V&V and integration and implementation aspects, where the gaps are, that's where you could fill the gaps with systems engineering, and that would vary from organization to organization. So sometimes that is looked at as systems engineering doesn't get into the details because it is so contextual. What works for one organization did not work for another organization. What works for one discipline did not work for another discipline. So that factor is always there. So that's where you need to take a careful look of existing CMMI and other procedures and processes that are there, and the value that they bring in, and how systems engineering can involve those, at the same time fill in what gaps may exist beyond CMMI, beyond Six Sigma, and beyond all those things.
Any other question or comments anyone would like to share? And just a reminder again to fill out the feedback survey also. Maybe I would like to just open the floor to everyone, just asking about what is the current state of systems engineering adoption in your organization, and what's the current one big challenge that you see, if you would like to share with the group. Or it could also be a best practice that you would like to share, that you've used to overcome that challenge.
Hi, this is Prasad here.
Yes, Prasad.
Here, one of the challenges which I feel is challenge in my organization. Traditionally, the company was mechanical product company with strong history of competence in business leadership. Recently, when we started integrating the electronic aspect into the products, and now it is IoT based business. The challenge what I see is people are used to maintaining the requirements for earlier designs in the Excel sheet or some document or something, whereas there was a parallel organization within the company itself which was a software intensive, and they used requirement management tool like Azure DevOps for requirement management. We have a big challenge right now, since the only guys using the tools for requirement management was Azure DevOps. They didn't want to change it for them. We are forced to use for system requirements and all everything Azure DevOps, but mechanical and hardware electronic guys are catching up with this, but they have no preference over where to store requirements and life cycle and everything. They think that system engineer is responsible for managing everything, so go handle it yourself. It is difficult to integrate any other things into Azure DevOps, and that's quite a challenge. While we say system engineering tools and processes, but investment of the tool, if we propose something, organization doesn't see value in bringing in something like a doors or some. And in fact, earlier we tried for a couple of years IBM doors, and it was so expensive, and people think it was waste of time, and they said go manage it somewhere else. It's easy. It's not a complex as a air or military kind of application. Yeah, so this is the challenge we see. Investment in the tool is a challenge.
Thanks, Prasad, for sharing that. And yeah, I have seen people struggling with just the Excel and doors, but you had Azure in parallel. So any workaround right now, or like a workaround in terms of process that you have?
In fact, I think right now we are using Azure DevOps for requirement management, though it is a tool which is a single source of truth and everything. A lot of integration work, like all our verification and validation traceabilities, which are like some are in mechanical testing, sits in some system called as some test track pro kind of a tool they have. System test hardware and hardware testing sits somewhere else. So we have to do manual linking to those traceability. It is not an integrated single tool having everything.
Right.
Additional burden on system engineers. At every review, we have to make sure that up-to-date test results are provided, the linkage and everything.
Right.
It's a challenge, but right now we don't have any solutions for that. We have to spend some time on that doing.
Sure, Prasad.
So quick question. So did you actually purchase doors, or you were considering doors and you're facing?
Before I joined, I think at that time, because we have big team in US and small team in India, US teams, sometimes they used IBM doors, I think about 2016 time or so.
All
and
right.
they thought it is expensive. It is not adding justification.
All right. Sure. Thank you.
Let's continue.
Thank you. Thank you.
Prasad.
Prasad, this is Ajit. Thanks for sharing your experience. And I would like to connect with Deva's, initial slides, why you want to do system engineering, wherein he touched base upon, establishing the current as is state, and also, the scope and goal for going towards the system engineering, and then that forms the basis of it. What point you raised about cost of tool and of course support of management around the cost, as well as some of the other initiatives, that's a very realistic problem, and the approach I just would like to bring to the group here is what Deva pointed out in the initial slides of establishing as is and thinking where you want to go, and then collecting the rationales on the way could help you to find the right combination of the tool, as well as means and measures of determining the ROI. Okay, that's basically the management is looking for. Deva, if you want to add something.
No, yeah. So that's kind of what I was hinting earlier, that you need to be able to claim benefits of systems engineering and then show evidence that you have met them, and that's where it becomes very critical. Sometimes we ourselves are to blame when we make some very ambitious, tall claims. Right? On what basis? We must be mindful. I also mentioned that baseline is not always available. So when a baseline is not available, it is very difficult to say how much saving you are having, you're producing, or what benefit you are producing. Make sure that baseline is established, and only then you can say we are doing things better.
So it's almost time. It's actually 3 minutes above 5, but we are happy to stay back for another 10-15 minutes if required. And if anyone wants to continue to chat with us or discuss any challenges or share any thoughts, we'll be very happy to discuss. And if not, we thank you all for joining us, giving us your busy schedule, time from your busy schedule, and participating, actively participating with us. So thanks again, and
thank you all. Yeah, it was a great learning session. Bye.
Thank you, Ramesh sir.